In this video, we're going to look at the different layers of the atmosphere. In the previous videos, we looked at how density and pressure change through the atmosphere. In this video, we're going to focus more on temperature. Because of the ways that temperature changes in the atmosphere, this is going to separate the atmosphere into four main regions. And these are the layers of the atmosphere. So temperature changes with height. If you go up in altitude, at least close to the surface, you'll notice that the temperature drops. Well, same with density and pressure, as we saw in the last couple of videos. Density and pressure always decrease with increasing height. However, at times, the temperature's behavior changes. There are some points where the temperature actually rises with increasing height. Okay? And so it becomes a little more of an interesting question when we talk about temperature's behavior with increasing height. The rate at which the air temperature decreases is called the temperature lapse rate. And I'll show you what the average lapse rate is here in the next slide. But there are a couple of specific lapse rates I want to talk about. First, a temperature inversion. Normally, the temperature will decrease as you go up in height, but occasionally the air temperature may actually increase with height. And when this happens, you go higher in the atmosphere and it actually gets warmer. We call that an inversion because it's inverted from what we are used to. We're used to the temperature decreasing. Now, somewhere in between those two, you have a layer where you have a temperature that remains constant with height. We call this an isothermal layer. Iso is a Latin term meaning same, and thermal is a term meaning temperature, same temperature. So isothermal is a region of the atmosphere where the temperature remains constant. We will see both isothermal layers and inversion layers in our atmosphere. Okay, let's start off with the lowest part of our atmosphere. This is the part of the atmosphere we live in. It's where we see all of our weather and so on. It's called the troposphere. And you will see how this fits in with the entire atmosphere in the next couple of slides. But this is the lowest layer of the atmosphere. It's the very bottom. Temperature does drop as we go up in altitude, as we mentioned before. How quickly? Well, it varies from day to day. But on average, if you were to rise up in altitude about 1,000 feet, temperature would drop 3.5 degrees Fahrenheit. Okay, so temperature does drop fairly quickly, but we're not going to use Fahrenheit and feet in this course. We're going to use degrees Celsius and kilometers. So converting that from degrees Fahrenheit and feet to Celsius and kilometers, it's about 6.5 degrees Celsius every kilometer. Go up in altitude 1 kilometer, on average, the temperature will drop 6.5 degrees. Now, this is the layer where our weather that we know, our everyday weather, where it occurs. It has a depth of about 11 kilometers, which is about 7 or 8 miles. Get the right unit there. So that's about how deep this troposphere is. That's the layer of our atmosphere where weather occurs. Now, at the top of the troposphere, the temperature actually stops decreasing, and you get yourself a small, very narrow isothermal layer. This is called the tropopause. Okay, the troposphere, and above that is the tropopause. This marks the boundary between the troposphere and the next layer, which is the stratosphere. Now let me go to the next slide and point out where the troposphere and tropopause are. Here we go. The troposphere starts off here at the surface. Temperature drops on average at a rate of 6.5 degrees Celsius every kilometer, up until a height of about 11 kilometers, 7 or 8 miles up. And then the temperature stops dropping and you get a small layer where the temperature stays the same. That's called our tropopause. Now, why does it do that? It's because right around that altitude, just above that altitude, you have a layer of the atmosphere that we often call the ozone layer. That ozone is just a molecule of 3 oxygen atoms combined into one molecule. That's ozone. Ozone is really good at absorbing ultraviolet radiation, ultraviolet light, if you will. And it absorbs it so much that it actually warms up the ozone and it warms up the atmosphere itself. And so the temperature actually starts to rise because it's absorbing that sunlight. You've got an inversion layer where the temperature rises with altitude. This layer is called the stratosphere. All right. It extends from about 11 kilometers in altitude up to about 50 kilometers in altitude, up to about 30 miles. Okay. By the time you get to the top of the stratosphere, your pressure is only about 1 millibar. So basically, you started off with a pressure of 1,000 millibars near the surface. Pressure is now 1 millibar up here. That means you're on top of 99.9% of the atmosphere at this point up here. Anyway, on top of the stratosphere, you get another small isothermal layer, which we call the stratopause. See the patterns? Troposphere, tropopause. Stratosphere, stratopause. The pause layer is the isothermal layer on top. Well, what happens above that? Above the stratopause, you get out of the ozone layer, and the density of molecules starts to become rather low. Extremely low is probably a better way of saying it. So low that it has a hard time absorbing enough energy from sunlight. And so it gets really cold. You get another layer where the temperature drops with altitude. In fact, the top of the mesosphere, this is the coldest part of the atmosphere, right up here at the mesopause. Sorry, I should move to the next slide so that you can see what I have written here. Meso just means middle. This is the middle of our atmosphere. Well, relatively speaking, we're almost out in outer space at this point because we're on top of 99.9% of our atmosphere or more. So that's the mesosphere and the mesopause. Now, finally, above that, you get into what's called the thermosphere. This is where you see a lot of the really cool stuff like the northern lights, also known as aurora. All right, up here in this thermosphere, oh my goodness, I just realized I have a typo here. I should fix that. It's not an isothermal layer. It is an inversion layer. The thermosphere is an inversion layer. All right. The temperature increases with altitude, and that is because there's nothing to protect those molecules. Any molecules up in the thermosphere are exposed directly to sunlight, and so they heat up very quickly. And you end up with temperatures in the 500s or even into the thousands of degrees Celsius. And that is the thermosphere. All right, now one last point. When you look at the composition of our atmosphere from the ground until very nearly the top of the mesosphere, or maybe even the lower part of the thermosphere, it varies from day to day. The composition of the atmosphere is rather uniform, meaning through this entire layer, troposphere, stratosphere, and the majority of the mesosphere, you're going to see 78% of the atmosphere is made of nitrogen, 21% made of oxygen, and just under 1% made of argon. All of those percentages we saw in the origin and composition of the atmosphere video. But above that, because of the interactions with sunlight, you start to see different separations. You might have a layer where there is a very large concentration of atomic oxygen. You might have a layer that has a high concentration of helium. You might have another layer that has a high concentration of hydrogen, and it varies from place to place. So we call this the heterosphere. Heterosphere, meaning you have pockets of different gases. Homosphere, meaning everything is very uniform. There's one other layer of the atmosphere we need to talk about, and we just talked about the temperature profiles of the atmosphere. And these layers of the atmosphere we're going to look at through the entire semester. We're going to focus primarily on the troposphere. That's where our weather is that we're going to deal with. But often we'll have to go into the stratosphere and even a couple of times into the mesosphere. Okay, but these are the 4 layers of the atmosphere we are going to be most concerned with. But there is one other layer that we need to talk about that's not related to temperature, and that's going to be in our next video, and that is what we call the ionosphere, our topic of our next lecture.